specific interaction, so how two species can impact each other's population growth. We discussed that we need a equation for each species involved. We'll never go past two, so we have two equations, one for species 1 and one for species 2. We have hopefully been looking at that, and you're going to learn that equation, and you're going to learn the different parts of the equation. Then at the end of class, we were talking about how the population size of species 2 can reach a point in which it completely suppresses species 1, and that species 1's population can potentially get to a size that can completely suppress the growth of species 2. Okay? And that's kind of where we were. So I was starting to put the models on the board, the axes of the models on the board, and then we stopped. All right? Y'all remember that mostly? Remember everything I just said? I did say that there are 4 possible outcomes we're going to discuss today. Species 1 wins, species 2 wins, a stable coexistence in which they can live together, and then an unstable coexistence in which they could potentially be coexisting if it hits one particular plot on the graph. Otherwise, species 1 could win or species 2 could win. It just depends. So it's going to be, that's why it's unstable. Okay? So that's what we will be doing. Before we do that, though, I'm going to draw some graphs that you can use as reference, where I'm going to put species 1 and species 2 on our axes. So let's start with looking at what happens with species 1. And so on all of our axes today, we're going to put N1 on the x-axis and N2 on the y-axis. We're just always going to do that, or that's not going to change at all. But what we're going to do in this case is just look at what's impacting species 1 before we put species 2 on the graph, essentially. All right? Okay. And so we did a little bit of this already. We said that the population of species 1 is moving along the x-axis. And so this would be low, 0 essentially. This would be higher. And so as we work with species 1, it's going to be moving either lower or higher. It's always going to be moving in this direction. Okay? And then at the end of class, we said that the population size of species 2 that will completely stop the growth of species 1 is K1 over alpha. So the carrying capacity of species 1 divided by the competitive impact of species 2 on species 1. And that will cause the population of species 1 to be 0. So far, okay? All right, so then what we're going to do is we're going to have these lines, and they're going to stretch. Whoops, I forgot to put K1 down here. All right, so along here we have to have our carrying capacity, so there's K1. So we had that on there. So that's the population size that the environment will support, K1. All right, then what we're going to do is we're actually going to draw a straight line from K1 over alpha to K1, like so. This is something called an isocline. I'm not going to really write that on the board. Not worried about that too much. It just means that everywhere along this line the value is the same. And in this case, the value that it's talking about is r equals 0. And specifically, we're talking about species 1. So this is r1 equals 0. So everywhere along this line, r1 equals 0. So here, and here, and here, r1 equals 0. And just a friendly reminder, I think we've got it at this point, but just a friendly reminder, that doesn't mean that birthing and deathing has stopped. Just means it's in balance, r equals 0. All right, now here's the part that we need as we begin to build our models. If you get above this line, then we are higher than the carrying capacity and the competitive impact of species 2. And so everything above this line, R1, is going to be negative. R1 is going to be negative. And what that means is we're going to be decreasing. Right? The population size of N1 is going to be decreasing. And so, if N1 is moving back and forth in this direction, are we going to go this way or that way if we're decreasing? We're getting smaller numbers. This way. Right? And again, it doesn't matter where we are on the graph, as long as we are above this line, the R1 line, R1 is decreasing. Everywhere below the line, R1 is going to be positive, which means that it is increasing, and therefore the arrow should be going the other way, increasing in number. And that's true for everywhere below this line. We're increasing towards the K1. We're increasing towards this, actually, the isocline. All right. Anybody have any questions about that?
That's just for N1.
That's just what's happening with N1. We do have N2 in here, but we're not looking to see what the line does for N2 yet. So we're going to do them separately, and then we'll put them together. There's graph B. I told you I would bring my notes to try not to confuse us. All right, let's look at, again, species 2 by itself. Okay? Sort of, because we are going to have N1 along our x-axis, N2 along our y-axis, just like before. They are actually interacting in this graph. I just want to look at what the population of N2 does, just like we did in the first graph, but this time kind of focusing on that. And so in this case, N2 is over here, and so this would be a low population size down here near 0, and this would be high up here at the top. And so the population of N1 is moving up and down in this direction. So if we put an arrow like I did last time, it's moving in this direction, up and down. And so if you're increasing the number of individuals of N2, it's going to go up. If you're decreasing the number of individuals of N2, it's going to go down. Okay, and so there are two things we need to mark on here, so we can also get a nice line, an R2 equals 0 line. And so along here, somewhere, will be the carrying capacity of species 2, so K2. And then maybe this triggered some memories, but what is the population size of N1 that stops the population growth of N2?
K2 over beta.
K2 over beta. Okay. Again, that's the carrying capacity of species 2 divided by the competitive impact of species 1 on species 2. And then just like before, we're going to connect this line, or connect these two things to get a line. And everywhere along this line, no matter where I want to be, R2 is 0. So that's our 0 line. If we are above this line, then we're above the carrying capacity, and therefore R2 is going to be negative, or it's going to be decreasing. And since it moves like this, which way would I put my arrow? Up or down? No, it's going to go down. It's going to decrease, so it's going to go down. And again, it doesn't matter where I start, anywhere in this graph, we would be going down. If you are below the R2 equals 0 line, then R2 is going to be positive, which means it is increasing. And therefore, anywhere I start in this triangle, it's going to be going up. Okay. And so if you can handle this, we should be good. We should be able to put this all together. Any questions so far? Okay. See, this though is artificial because in reality we need to have both these lines on the same graph. You have your N1 line and your N2 line on the same graph. Then we're going to look and see what happens in each of the sections that the graph forms, and that's going to give us the potential outcome essentially. Okay? And so when you're first getting started, you could potentially find this confusing. This is something that you can refer back to make sure that you remember which way R1 moves versus how R2 moves. Okay? But I don't have to erase it. I think I told you one time they had me in a math classroom and I had boards all the way around the room, and I had all of them up at once, and it was actually really nice. It would be helpful for this lab, but we can't do that today. We just have one board. And I felt so impressive, and I wanted to leave it up for all the rest of the classes that day, right? Because even though it's not that hard, it does look impressive if you don't know what's happening, right? Okay. Let's look at a situation where we do this correctly and have both species on the graph. And let me make sure I go in order so as not to confuse myself. See, I'm already confused myself. We're good. All right. So, like I said, our x-axis and our y-axis are always going to be N1 on the x, N2 on the y. We're always going to mark the carrying capacity for species 1, which is K1. And we're always going to mark the carrying capacity for species 2, which is K2. Just make sure I'm leaving myself space to put the other stuff on. And then we need the population size of N1 that stops the population growth of N2. And so in this case, I'm going to put it right here, K2 over beta. And then we need the population size of N2 that stops the growth rate of N1. And I'm going to put it up here, K1 over alpha. Okay, this is what I tried at the end of class before I confused us at the very end, to get us to think about before. And so in this case, if N2 can only reach a population size of this is all that the environment will support, it can never obtain this population size, and so it can never exclude N1. Right? And if we look down here, here's what the environment will support of N1, which is higher than what it needs to suppress species 2. And so just thinking about these axes, which one of our 4 possibilities do you think this is? Species 1 wins, species 2 wins, coexistence, unstable coexistence.
Species 1 wins.
This is going to be species 1 wins. Okay, species 1 wins is what we're working on. All right, but let's look at how to put this model together. One thing is always remembering what gets connected. And so the things that are impacting species 1 is going to be K1 over alpha. And so we're going to connect that. And then impacting species 2 is K2 and K2 over beta. So we'll connect those 2 lines. Make sure I haven't done anything wrong. We're looking good, looking good. And then on your homework and on the exam, I'm going to ask you to report what R1 is and R2 is throughout the graph. Okay? And so this line right here is our R1 equals 0. That's our 0 growth line. And so this line right here is our R2 equals 0, or the 0 growth line for R2. And that leaves us 3 parts of the graph that we need to account for. And each one of these, we want to say what R1 and R2 is doing. Let's start easy. Let's start out here. So we need to know what R1 is, and we need to know what R2 is. For R1, here's our 0 growth line. We are above it, which means that we need to be moving back towards it. And so we're going to be decreasing. And if I say something and you think first of all, if you think I'm wrong, let me know so we can correct it if I am. And second of all, so we can explain what's going on. All right, here's our R2 line. We're definitely above it as well. And so that's going to be negative. And then the next thing I'm going to do is I'm going to ask you to show your trend lines for R1 and your trend line for R2. But what the model is going to do is average those two lines. Okay? You can put your dot anywhere you want to up here. I'm just going to choose right here because I've got some room. And so let's start with R1. R1, our population size of species 1 moves in this direction. We're decreasing, and so we need an arrow that's pointing this way, representing R1 decreasing. R2 represents population 2, so the population size of species 2 moves in this direction. And right now we're decreasing, so that's going to give us a downward arrow for R2. And then what the model does is it is going to average those two arrows, which gives us a general trend in this direction. So in other words, when you run the model with those two equations, it's not going to go straight this way or straight that way. It's going to be an average of what's happening between those two species. Okay? Everybody okay? All right. A lot of times, especially on your homework, you don't have a lot of room right here in this triangle, and so I'm fine if you want to do something like this. Okay? And so again, we need to see what R1 is and R2. What are they doing? For R1, we are below the zero growth line, so it says room to increase. For R2, we are below the zero growth line, so we have room to increase. And so let's just put our dot right here in the corner. For species 1 to increase, we're going to go in this direction, put a short arrow there. For species 2 to increase, we're going to go upwards, so we'll put a little line there. And then to represent the model, we'll just average those two lines. That one much faster. We'll continue to get faster, especially those two triangles. Because the interesting spot, of course, is going to be right here in the middle. And so right here in the middle, we need to know what R1 equals and R2 equals. And this is where, just to avoid confusion, you need to pay close attention. And so here is our R1 zero growth line. We are below it, which means that the species 1 has room to grow. So it's increasing. So let's just choose this dot right here. So it's increasing. Oops, I didn't do it very flat. I'm trying to be a role model up here, right? Let's do it flat. There we go. Okay. However, we are above the zero growth line for species 2, which means it is decreasing. So I need a small downward arrow for it. And then we take the average. And so what you need to keep in mind is that idea that I'm saying you can put your dots wherever you want to, but no matter where you start a dot, so if I put a second dot right here, for example, it's going to be the same thing. Put another dot right here, it's going to be the same thing. And so it doesn't matter where you start, it's going to move into this area and go to here. Or it's going to start here, move into this area, and then go to here. No matter what point on this graph you start at, you're going to end up right here. Okay. Is everybody okay with that? It's going to be like, woo! Okay, so everything goes to there. Although I made my graph look ugly now, don't do that to yours. All right. Another thing I want to ask you to do on your homework and on the exam is label your stable equilibrium points. And so this is a stable, or all your equilibrium points, stable and unstable, I should say. So all your equilibrium points. This one is stable. And then I kind of already did this. The other thing that I'll ask you to do is state the winner, or state the outcome. And so I've already done that up here at the top. So here's your outcome. Species 1 wins. No matter where you start on this graph, species 1 wins. All right, any questions about the first one? Okay, on your homework, I give you a really fun exercise in which I give you the arrows and you have to figure out which model it is.
Ooh, that's fun.
It is kind of fun. Ew, it's not hard. I'm pointing it out right now. I'll give you 2 of them on this homework. Because the arrows that are important is not this arrow, right? It's not this arrow. It's the ones in the middle. And so if you get a situation like that, and in the middle you see all arrows doing this, you know it's this particular outcome, right? Because remember, there's only ever 4 choices. Okay. All right. Any questions before we go on to the next one? All right, so for the next one, what we want to do is to flip these, like that. We're just going to flip them for our second situation. So again, we have N1 and N2. My family is having a big discussion again about what we're having for Thanksgiving. So my pants are vibrating. Well, I should probably turn it upside down. Maybe put it on here so we don't hear it so much. There we go. Still like 2 weeks away, right?
That don't matter. We were preparing like a month ahead of time.
Yeah, this has been going on for a while. So at one point, I was getting kind of annoyed, and I texted, I'm in charge of the turkey and the pumpkin pie and quinoa, because I like quinoa. So that's what I'm bringing. I announced that the first day we did this, right? I'm bringing the turkey, pumpkin pie, and quinoa. So then I was like, I changed my mind. I'm going Charlie Brown. I'm bringing toast, popcorn, jelly beans, and pretzels. Forget it. No turkey for you. Okay. So we're going to flip these. So now K2 is going to be up here. And K1 over alpha is going to be there. And then we're going to flip these. So we're going to have K1. Let's put it about right there. And then K1 over, or K2. Whoops. K2 over beta. Okay. So again, before we put our lines on, we have a situation here in which N2, according to the environmental limits on the environment, can reach a population size of this high, but it can completely drown out species 1 if it can at least get this high, right? And so can it do that? Can it reach this population size? Sure, because the environment will support a population size of this big. Down here, however, K1, or how many individuals the environment will support for species 1, can only get to here, and they need this many individuals to outcompete species 2. So can they obtain that? No. And so what's going to be the outcome here before we even do it? Right, outcome while I'm stretching. So the outcome is going to be species 2 wins. Okay. All right, so make sure again you connect up the right lines. So K1 over alpha goes to K1. K2 goes to K2 over beta. And then these corners are just not going to change, right? As long as you are outside of these lines where all the action is happening. And so this part is just the same as it was before, so make sure I just don't make any mistakes. And if you ever have any confusion on it, let me know. Why did I put ones instead of dashes?
Yeah.
Probably because I like Jelly Bellies, and maybe that is what I want for Thanksgiving. See if I did better this time. Whoops. I screwed it up again. Gotta get my focus back. Here we go. I think I got all that on there correctly. Finally. All right. And so the interesting part's in the middle. If there anybody we need to review the corners, we can do it later. That's why we do our homework together. Okay. So let's say I start right here. We need to know what R1 and R2 are going to be. And so for R1 this time, we're above its zero growth line, which I have forgot to label. Alright, so we are above the R1 zero growth line, which means that it is decreasing or moving in this direction. But we are below R2 zero growth line, so it's positive, which allows it to increase. And so if we average those two arrows, we're moving in this direction. Okay, I went faster. I'm going to speed up as we're doing this. This one's just the reverse of what we just did though. And so in this case, we're always going to end up here. Again, no matter where you start on this graph, you're going to end up here. And so this is a stable equilibrium point. I think I got everything labeled that time. And again, when I give you the arrows and tell you to fit the lines to the arrows, if the arrows in the middle are going like this, that's a pretty good sign as the outcome, right? Okay, so here's two of our possible outcomes. Species 1 wins, species 2 wins. But we have two more we need to do. Coexistence and unstable coexistence. And so how are we going to get to those? What should you never do in Ghostbusters?
Cross the stream.
Cross the streams, right? So we got to cross the lines, and that's how we'll get our next models. Okay? All right. Okay, let's set up our next model. Starting out the same, in 1 on the x-axis, in 2 on the y-axis. Make sure I'm going to put this one first. So I'm going to hide the other one. Hopefully that helps. Okay. For this one, I'm going to say that K1's about right here. And K2 over beta is outside of it. Okay. So before I put anything up on the other axis, this is as big as the environment will allow the population of species 1 to get, but it would need to get this big to exclude species 2. So can it exclude species 2? No. And then over here I'm going to put K2, and I'm going to put K1, whoops, there we go, over alpha up here. And so let's do the same thing. This is as large as the environment will let species 2 get, but it needs this many individuals to outcompete species 1. So can it outcompete species 1? No. And so what would you predict the outcome to be?
Coexistence.
Yeah, this one's stable. It's going to be coexistence. Okay. When you're doing these where the lines cross, make sure you're careful. And so we want to connect K1 over alpha to K1. And K2 to K2 over beta. Now lines are going to cross. This one, top one, the K1 to K1 over alpha, is the R1 equals 0 line. I think I'm going to put the other one. Yeah, I'm going to put that right here. So this is the R2 equals 0 line right here. This part and this part of the graph, unchanged. So we just need to make sure I write it on correctly. All right, and this part doesn't change. I didn't put ones this time, that's an improvement already. Okay. Everybody okay with everything I've put on there so far? This is another place where it's going to be kind of small in here. And so I'm okay again if you want to do like, this is where you're going to write your R1 and R2 for this triangle. Okay. Now let's look at this triangle and see what's happening. Here's our R2 line. It's the top line. In this triangle, we are below it. And so R2 is positive. Here's our R1 line. We are above it. And so R1 is negative. Okay? And this is where you have to just kind of think. So if I start right here, if R1 is negative, that means it's decreasing. So it's going to go this way. R2 is positive, which means it's increasing, and it's going to go up. And so we average those two, and we move in this direction. Everybody okay with those arrows? Okay. And the same thing here, it gets a little squished, so I'm going to put my R1 and R2 for that section up here. This is our R1 line. And so in this section, we're below it, which means R1 is positive. Here's our R2 line. We are above it, so R2 is negative. So if I start right here, R1 is increasing, R2 is decreasing, and there's my average. Nobody looks like they're gonna kill me, so I think we're okay. Like I did before, don't put arrows on here to do it, but no matter where I start, again, I'll start here. If I end up here, I'm going to go to here. If I start here, end up here, I'm going to go to here. These, of course, are already pushing to the middle if you're right in the middle. And so no matter where you start on this graph, you're going to end up right here. And so this represents a stable equilibrium point. Stable equilibrium point. And of course, we've already got our outcome, it's coexistence. Okay, to review our important arrows on our graph, this is where I need to become a cheerleader. Species 1 wins, right? Species 2 wins. Now we have them doing this, right, at each other. Okay? I don't know that I did that great, but you again don't seem confused, so we'll go on. All right, any questions about coexistence? All right, we have one more. And all the answers on the exam, or well, yeah, on the exam and on your homework is one of these four. And so the outcome by process of elimination is going to be unstable. That's coexistence, which is our most complicated one. Let me move it so that I can expose that one. Try not to make it too complicated. So what are we going to need to do to our axes to cause this to happen? We're going to need to flip these, right? Because if we flip these, then our lines will still cross, for one thing. And we've got to have our lines cross in order to have our fourth option. And so on this one, we're going to have K2 over beta, and then K1. And so we've created a situation in which if we're just looking at the population of species 1, the environment will support this many individuals without species 2 around. And so can it obtain a population size that will completely suppress species 2? Yep. All right. Now we need to do the same over here. So let's make this line K1 over alpha and this line K2. And we have the same situation. The environment will support this many individuals of N2 if N1 is 0. And so it can exceed a population size which would suppress N1. Okay? Let's connect up our lines. Make sure you're careful about this. So K1 over alpha goes to K1. And that's going to represent our R1 equals 0. And then K2 is going to join up with K2 over beta. And that's our R2 equals 0. And then here and here doesn't change, still the same. So up here, R1 is negative, R2 is negative. Okay. Down here it doesn't change. Okay. So what's interesting again is between the points. Okay. And we don't have a lot of room. I'm going to start down here. We're going to do R1 and R2. So here's our R2 line. We are above it, which means it needs to decrease. Here's our R1 line. We are below it, so it's going to increase. I'm getting tired, so I'm checking to make sure I told you right. I did. So let's put a little dot in here. R1 increasing, so it's going to go that way. R2 decreasing, so it's going to go down. So we get an arrow that looks like that, going away from center. Okay. In this triangle, okay, here's our R2 line. We are below it, so it gets a positive. Here's our R1 line. We're above it, so it gets a negative. Start right here. R1's decreasing, it's going to go that way. R2 is increasing, so it's going to go up. And you get an arrow that looks like this, so split. So now we're species 1, species 2, coexistence, and then we have the unequilibrium. They're going to point opposite of each other. Okay. All right. But we have 3 points on this graph that are important. All right. If from this direction, anywhere you start in this part of the graph, that's actually going to shoot you to the middle right here. And if these two populations can stay at that point, they can coexist. However, this is an unstable equilibrium point. And the reason why it's unstable is that if anything happens, it'll shift you either into this triangle or this triangle. If you get shifted into this triangle, then this graph is going to take you down here. And if that happens, this actually is a stable equilibrium point. And in this case, species 1 wins. If we make the equilibrium point and something in the environment causes a shift and we end up in this triangle, then that's going to shoot us up here, which again is a stable equilibrium point. And species 2 wins. Okay, so there's a lot going on in this graph. All right. I want to look at the first problem in which I give you arrows only. Let's look at that one together for a second.